Hi there! In this video, we're going to find the first 5 terms for 5 different sequences. And the key to sequences is the variable n, which represents the position of the term. And to find our answers, we simply replaced n with the numbers 1, 2, 3, 4, and 5. So, let's start with our first example. For our first example, a sub n equals n plus 4. For the first term, we have a sub 1. We plug in 1, so this is 1 plus 4 equals 5. For the second term, it's gonna be 2 plus 4 equals 6. A sub 3, we have 3 plus 4, we have 7. And continuing, we have 4 plus 4, it's 8. And 8 sub 5, that is 5 plus 4 equals 9. So our first 5 terms are 5, 6, 7, 8, and 9. So this is the first 5 terms for n plus 4. Okay, now we have to move with our second example, which is a sub n equals 2n minus 1. For the first term, we have a sub 1, that is the first term. So we replace n with 1, so we have 2 times 1, and then minus 1. So 2 times 1 is 2, minus 1, it's equals to 1. A sub 2, we have 2 times 2, that is 4, minus 1, it is 3. For the third term, we have a sub 3, so 3 times 2, this is 6 minus 1, so we have 5. And we follow that logic, we have a sub 4, this is 9. And notice that the first odd numbers we have here notice that these are first 5 odd numbers because the sequence is 1, 3, 5, 7, 9. So therefore we have these 5 terms that are odd numbers. Okay, so that is for example number 2. Next we have a sub n equals 12 minus 3n. Since we are subtracting, our terms now will decrease. So notice we have term 1 have 12 minus 3 times 1, we have 9. Term 2, it's 12 minus 3 times 2, we have 6. So it's giving us 6. Term 3, we have 12 minus 3 times 4. It gives us 3. Sorry. This will give us 3. And then following that logic, we have 12 minus 3 times 4, that is 12. So what we have now is 0. Now for the fifth term, or term 5, that is 12 minus 3 times 5. 3 times 5 is 15. Therefore, we have negative 3. So our sequence, or the five first terms is 9, 6, 3, 0, and negative 3. And this is in decreasing order. Okay. Now we move forward with example number 4. And this example 4 is exponential. So we have a sub n equals 3 to the power of n. Now for term 1, we have a sub 1 equals 3 to the first power, or 3 to the first power. Okay, so that is 3. A sub 2, so that's 3 squared, and 3 squared is equals to 9. We have a sub 3. Now we have 3 cubed. And 3 cubed is equals to 27. For the fourth term, we have a sub 4, 3 to the fourth power. And 3 to the fourth power is, if you type in your calculator, that is 81. And for the fifth term, a sub 5, that is 3 to the fifth power, we have a 243. And this example, so let's list it down. We have 3, 9, 27, and 81, and 243. And this is the first 5 terms, and this is an example of a geometric sequence where each term is multiplied by 3. As you notice, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So this is an example of a geometric sequence. Okay, so that's the first 5 terms for this one. Let's move to our last example. So this is alternating signs. So we have here a sub n equals negative 2 to the power of n. And pay close attention to the negative base. Here, the negative sign. Forgot the equal sign. Okay. So let's start with term 1. Term 1, that's a of 1, or a sub 1. So this is negative 2 to the first power, and negative 2 to the first power is negative 2. term 2, we have negative 2 to the second power, or negative 2 squared. If it's a negative 2 squared, it will become positive 4, because a negative times a negative is positive. So that's negative 2 times negative 2, it becomes positive 4. You have a sub 3, which is the term 3. So this is negative 2 cubed. This is equals to negative 8. Notice the sign. A sub 4, that is negative 2 to the 4th power. Since it's a 4th power, the answer is positive 16. And we have term 5, or a sub 5, negative 2 to the 5th power. This is negative 32. So our sequence, first 5 terms for this sequence is negative 2, 4, then negative 8, 16, and negative 32. And you can notice how the signs alternate back and forth between negative and positive, negative and positive. So that is an example for alternating signs. So I think that's it. That covers the 5 examples. Okay. Now, just remember to substitute the position number for n and follow the order of the operation. So you need to be very familiar with algebra to get the first 5 terms. Now, I think that's it. Thanks for watching.